I'm Cheryl Whistler. I'm a full professor of molecular, cellular, and biomedical sciences at the University of New Hampshire, and I've been here for 13 years. So we are right now in the Northeast U.S. experiencing a pronounced increase in shellfish food poisoning from a pathogen that had not previously really caused problems in this area. And it has caused some problems in the Gulf of Mexico and the Pacific Northwest, but in the Northeast it was not really an issue until a highly pathogenic strain was introduced into our shellfish harvest areas by an as yet unknown mechanism. So I have worked to develop an assay that specifically identifies this pathogenic strain of Vibrio parahemolyticus. So the assays that are currently approved for use by the FDA identify some genetic characteristics, but those characteristics are also found in non-pathogenic bacteria. So it tells you if the genes are there, but it doesn't tell you whether or not the genes are in a bacterium that's going to make you sick. So the innovation or the improvement on the methodology is that we can now detect not just whether or not they have these marker genes that suggest that they could be pathogenic, but we can detect the actual group of bacteria that do cause infections, and in particular they are family. So it's a family tree and we detect them by their relatedness. So we can tell exactly which organisms in the pool of organisms are the ones that are actually dangerous. And so we can quantify and predict risk better than the previous assay, which would be an indicator, but it wasn't definitive whether or not the pathogens were there. So somebody interested in the assay, it would be useful for them to know that I've built off of a standard assay that is currently used by shellfish managers. But it's an improvement and it does provide more useful and fine scale information. And the assay could also be expanded to be a different platform. So because it's a molecular tool, so we detect DNA that's present in the pathogens, it doesn't have to, it's not necessary that they use the FDA approved platform, which is expensive and requires investment in very high-end equipment. And it also requires clean room laboratory facilities, which restaurateurs are not going to have. So the assay could be developed to detect those markers in a different platform. And there are a few that we've actually looked into and discussed. So there are a few methods these days that allow you to make a kit that is literally self-contained, where you just would add your homogenized oyster and you would be able to detect whether or not this marker is at a high enough level to produce a risk that requires management. So the first application would be to assist managers and regulators in determining what is a safe level for harvesting shellfish and when is shellfish safe for consumption. But the managers are not the only ones that care. So the growers also have a lot invested in producing a safe product. They do not want their product to be recalled or make anybody sick. Nobody wants illnesses. So even though it's primarily initially developed for management, the applications could extend to growers being able to apply a simplified version of the test, and they could actually make some decisions about how they're harvesting their shellfish depending on how the levels of the pathogen have changed. The assay could be developed for use in the food market. So for anybody who is a marketer or a restaurant or somebody who distributes shellfish, for them to be able to detect whether or not a batch of shellfish that they have received has been handled properly and has not had levels of bacteria become really high. Having a simplified test based on the assay would be really useful for the commercial industry also.